Okay, so in this lab, we're going to investigate the properties of logarithms. And we're going to start in number 1 by evaluating the following logs without using a calculator. And the log of 1, remember, if you don't see a subscript there, the base is 10. That's a common log. So the common log of 1, that's asking us 10 to the x equals 1. So the common log of 1 is asking 10 to what power is equal to 1, and that would be a 0, right? Whenever you have a base to the 0 power, it always equals 1. Okay, then the common log of 10 would be asking the exponent on the base of 10 so that it equals 10. And that would be a 1 because 10 to the 1 is 10. Then the common log of 100 would be 10 to the x equals 100. And we want to know what's the exponent on the base of 10 to end up with 100, and that would be a 2. Okay, so we can see each time the argument of the log is multiplied by 10, right? The argument of the log is the number after the function log. So the common log of 1 has an argument of 1. If I multiply 1 times 10, that would be the common log of 10, right? Times 10 would be 100. So each time we multiply the argument of the log by 10, the value of that logarithm is increasing by 1 each time. So the value of the log increases by 1. Okay, so if we use that pattern in this table below, we know that the log of 1 is 0, the log of 10 is 1, and the log of 100 is 2, right? That's what we evaluated in number 1. Okay, now if I have the log of 200 and I know that that's equal to approximately 2.301, okay, if I divide by 10 the argument of the log, so 200 divided by 10 is 20, I'm going to subtract 1 from the value of the log to get 1.301. Right, if I divide that 20 by 10, that gets me to 2. Then I subtract 1 from the value of the log, and I have 0.301. Right, now if I try this one, here the common log of 7 is approximately 0.845. If I multiply the argument by 10, 7 times 10 is 70, I would add 1 to the value of the log. So I'd have 1.845. Right? Then if I add, or if I multiply the argument 70 times 10, I get 700. I add 1 to the value and have 2.845. Okay, so you're going to fill in the rest of that table, and then you're going to analyze the table to fill in the blanks for number 4. What pattern do you notice going across the rows?